In this video, I'd like to talk about the math question of the day for Monday, May 8th, 2023. And with this problem, we need to simplify this complex fraction here. Notice that we have a fraction divided by another fraction, or fractions within a fraction. And complex fractions are sometimes taught near the end of grade school, so maybe 6th, 7th, or 8th grade, or they might be taught in an Algebra 1 or an Algebra 2 class, depending on the school that you attend. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And with complex fractions, there are a couple different ways to approach this. One is to recognize that we're just dividing fractions here. This fraction bar, remember, just means to divide. So we could rewrite this as this top fraction, 3x divided by 7, and this is divided by this bottom fraction, 2x squared divided by 7. And it might be a little bit complicated because of the variables, but we just need to remember how to divide fractions. Let's say we have the fraction 3/4 divided by the fraction 2/5. When we're dividing fractions, you can remember the saying, keep dot flip. And the general idea is that dividing by a fraction is the same as multiplying by that fraction flipped over, or by that fraction's reciprocal. So we keep the first one the same, we change this division to multiplication, which can be represented by a dot, and we flip the fraction we're dividing by. And once we change it to multiplication, we can just multiply straight across, and for this example, we would get 15 divided by 8. So we can apply that principle here. We can keep the first one the same, change this to multiplication, and then find the reciprocal of this second fraction, or in other words, we'll just flip it over. We have 7 over 2x squared, and now we can just multiply straight across. We have 3 times x times 7, and I'll just write the 7 out in front, since we'll be able to cancel it with this 7 in the denominator. So we have 7 times 3x, and here we have 7 multiplied by 2x squared. And 7 divided by 7, we know that's just equal to 1, so we have 3 times x divided by 2 multiplied by x squared, which I'll write as x times x, since we can make another simplification. Since we have x divided by x, and something divided by itself is always equal to 1, one of the x's in the top and the bottom will cancel out, so that we will just have 3 in the numerator and 2 times x in this denominator. So this right here should be our final answer. And one way to check this, if you want, you can actually plug in values for x and simplify the original complex fraction, and then plug in that same value for x in the simplified answer here, and see if you get back the same numerical value. And I will leave that as an exercise to the viewer. Now, I do want to mention that the alternate approach, rather than rewriting this as just a normal division problem with fractions, we can also notice that the denominator for the numerator fraction and the denominator for our denominator fraction are both 7. So if we multiply the numerator by 7 and the denominator by 7, we can cancel those out right away, so that we get 3x up top and 2x squared down below. And essentially now we're at this step, which we know simplifies to 3 over 2x. So that approach will work as well. And notice that we're just multiplying top and bottom by 7. Or in other words, we have this entire complex fraction multiplied by 7 over 7, which is just 1. And we can always multiply by 1 without changing the number. But in both cases, we end up with the exact same expression here.